There are hundreds of billions of planets swept up in the massive whirlpool of the Milky Way galaxy. From Earth, a solitary outpost adrift on one of its spiral arms, humanity has begun gazing across the void. Only recently, scientists identified the first Earth-sized, habitable zone world that NASA's exoplanet program was established to find, in hopes of uncovering unmistakable evidence of life elsewhere. During this search for extraterrestrial life and Earth-like planets, NASA has also stumbled upon some astonishingly strange alien worlds. We begin with a brief look at the host stars of these planets, then examine these Earth-like discoveries themselves. PSR J1719-1438 is perhaps among the most fantastical cosmic objects mentioned here. To start, J7719-1438 is a neutron star, tiny yet unfathomably dense stellar remnants that usually measure no more than about 12 miles in diameter. Neutron stars are so dense that a mere teaspoon of their matter would weigh roughly 1 billion tons on Earth. This one is also a pulsar, meaning it emits powerful beams of electromagnetic radiation from its magnetic poles and boasts magnetic fields 1 trillion times stronger than Earth's. Some pulsars spin exceptionally fast, and J1719-1438 is a millisecond pulsar with a rotation period of 5.4 milliseconds, about 10,000 rotations per minute. But since we're discussing exoplanets, the pulsar's most remarkable trait is its companion, J1719-1438b, which has a mass similar to Jupiter's, but is only about 40% Jupiter's size. Scientists theorize this world is the stripped-down core of a former star, whittled away by the pulsar's intense magnetic field. What remains is primarily crystalline carbon, essentially a giant diamond, 5 times larger than Earth, and with a density that far exceeds that of any diamond here at home. Another mysteriously intriguing exoplanet orbits just 63 light-years from Earth. Known as HD 189733b, it was discovered in 2005. Its blue hue doesn't come from a watery reflection like Earth's, but from a superheated, hazy atmosphere laden with silicate particles. Daytime temperatures soar to about 2,000 degrees Celsius, with winds raging at 4,500 miles per hour. Under such conditions, it's possible that sideways glass rain might be falling there. This gas giant orbits only 2.9 million miles from its parent star, so close that it's gravitationally locked. One side is always facing its star. By contrast, Mercury is 29 million miles from our Sun. First spotted in 1999 and named for the Transiting Planets and Planetesimals Small Telescope, TRAPPIST, that led to its discovery. TRAPPIST-1 is an ultra-cool red dwarf star slightly larger, though much more massive, than Jupiter, located about 39.6 light-years from the Sun. In 2014, NASA pinpointed its first Earth-radius planet, Kepler-186f, confirming that planets the size of Earth can exist in the habitable zones of other stars. In 2015, astronomers used NASA's Spitzer Space Telescope and terrestrial observatories to find not just 1, but 7 temperate, rocky planets around TRAPPIST-1, each potentially able to hold up to 250 times more water than Earth. 6 of these worlds lie in what's considered the star's optimistic habitable zone. So close together are they that if you stood on one, you'd see the others in its sky, much like we see our moon. However, because TRAPPIST-1 emits a mere 0.05% of our Sun's energy, these planets exist in a cold darkness. Moreover, the star is anywhere between 5.4 and 9.8 billion years old. Every year, new exoplanets are detected. In early 2020, NASA discovered a planet matching Earth size and Earth star distance at around 13,000 light-years away, using a micro-lensing technique. It's considered to be a frozen ball planet, probably lifeless and so remote from its host star that some scientists suggest that the host may not be a star at all, but a brown dwarf. Yet even within our own solar system, possibilities exist for life beyond Earth. Titan, Saturn's second largest moon and second largest moon in the solar system, is the only other known celestial body in space, aside from Earth, with stable surface liquids. Typically, where liquids persist, so too can life. Titan is a planet-like moon, 50% larger than Earth's moon and 80% more massive. It has rain, lakes, and oceans, but not in the sense that we imagine on Earth. It also has valleys, mountains, ridges, mesas, dunes, even ice-covered areas and deep lakes caused by fierce winter storms, all while receiving just 1% of the sunlight we do on Earth. At first glance, Titan's conditions sound similar to Earth's, except Titan is bitterly cold, hovering around 290 degrees 179 degrees. Though we call some of its geographical features oceans and lakes, they're actually filled with liquid ethane and methane, and in such chill, those hydrocarbons behave much like water does here. Titan's atmosphere contains 98% nitrogen and 2% methane, and because it's far from the sun, scientists theorize that its warm interior, along with decaying radioactive elements, might heat it from within, creating a home-baked atmosphere. Could such a chemical and thermal environment harbor exotic life forms? Although it sounds improbable, many consider Titan's environment to be an outstanding lab for studying the kind of organic chemistry that may have predated life on Earth. Organic compounds, including amino acids, the building blocks of life, have been detected in several of Titan's regions. Some scientists go so far as to label Titan a deranged Earth, though they say it also closely mirrors infant Earth, before life changed our planet permanently. Beneath Titan's thick ice sits an ocean believed to be suitable for life, at least if we think about organisms that thrive in extremely hostile conditions. After all, we do know of tardigrades here on Earth, tough little creatures that survive both the vacuum of space and temperatures between 328 degrees and 300 degrees Celsius. They're resilient to harmful radiation, boiling liquids, and crushing pressures 6 times greater than in Earth's deepest oceans, needing no special protection. If these creatures can endure so much, who can say what else might exist on Titan? Yet the lack of surface liquid water leads some astrobiologists to doubt Titan's ability to support life. Nonetheless, microbial or single-celled organisms in Titan's methane seas remain a possibility. NASA believes enough evidence points to life that it plans to land a flying robot on Titan. We've been there once with the famous Cassini mission, and in 2005, the Huygens probe broke away and took a spectacular 2.5-hour descent video of Titan, ultimately landing among ice blocks along a dry shoreline shaped by rivers of methane. NASA's upcoming mission to Titan, called Dragonfly, will be a pioneering venture. Scheduled to launch in 2026 and arrive in 2034, Dragonfly is a car-sized quadcopter equipped with instruments designed to analyze large organic molecules. Powered by radioactive plutonium like NASA's Mars rovers, and armed with 8 rotors, it'll be able to traverse far greater distances than any rover with wheels. Because light signals from Earth take 43 minutes to reach Titan, Dragonfly must be significantly more autonomous, using advanced AI and specialized hazard avoidance systems to navigate and land. While airborne, it will sample the atmosphere and gather aerial imagery. Dragonfly's ultimate destination is Selk Crater, an ancient impact site with compelling evidence of liquid water, organic molecules, and life-fueling energy sources. This will be the 4th mission funded under NASA's New Frontiers program, which supports intermediate missions costing less than $1 billion. Dragonfly should come in around $850 million at launch. In about 5 billion years, when our sun transitions into a red giant and begins burning helium, it will expand and consume Mercury, Venus, and eventually Earth. Yet this solar evolution might warm other places, such as Titan, bringing its surface to around 94 off-dag, warm enough for stable oceans of water-ammonia solutions. With weaker ultraviolet light depleting Titan's haze and letting atmospheric methane create a greenhouse effect, Titan could become a sanctuary for exotic life for a few 100 million years, enough time for simpler organisms to develop, just as they did on Earth. In early 2020, NASA's Transiting Exoplanet Survey satellite, TS, detected TOI 700d in its star's habitable zone. It is one of the rare systems that might sustain liquid water. But until more observations are made, the planet's precise conditions remain unknown. This is where the James Webb Space Telescope, JWST, projected to launch on March 30, 2021, comes into play. With sharper infrared resolution and sensitivity far surpassing Hubble's, its $10 billion worth of gold-plated mirrors could capture the universe's earliest events and most distant objects, such as the first galaxies. Scientists are certain it will eventually uncover a planet brimming with life. After all, Earth still appears truly exceptional in our cosmic scans, but super-Earths that surpass our planet in habitability may yet surface. The quest centers on finding liquid water, since water so often begets life. Another new telescope set for October 31st, 2021, launch boasts cutting-edge technology that may finally unravel that big question. Is there another Earth, or a planet even better than ours, waiting for us to discover? Humanity may be on the brink of finding out. Earth remains the only planet we know of with large bodies of surface water, covering over 70% of its surface. Other inner planets, like Mars, may once have been wet and home to early life before becoming barren. However, spotting liquid water on an exoplanet is only the first step. If we find water on another world, there is a strong possibility that life is present. Virtually all living processes on Earth involve chemical reactions in a liquid medium. Observations from ground and space indicate that abstract water is among the universe's most abundant molecules. In fact, the Japanese spacecraft Hayabusa 2 recently returned asteroid samples containing water and organic compounds, evidence that certain asteroids are themselves sources, not just carriers, of such materials. Thus, countless water-rich super-Earths might be scattered across the cosmos. When hunting for an exoplanet with liquid water, astronomers check if it lies at the right distance from its star, so that it neither freezes nor bakes. Encouragingly, NASA researchers now contend oceans may be common in the Milky Way, but our present technology still can't directly confirm surface water. Instead, by analyzing atmospheric water vapor, we can infer that liquid water might evaporate from vast oceans below. In 2015, the Kepler Space Telescope uncovered K2-18b, an 8 Earth-mass exoplanet orbiting a red dwarf 124 light-years away. Its stronger gravity implies intense surface pressures, but in 2017, NASA's Spitzer data verified K2-18b's orbit in the habitable zone, circling its star in just 33 days. By 2019, combined analyses from Kepler, Spitzer, and Hubble revealed an atmosphere laden with 20% 50% water vapor. Scientists even suspect rain clouds might form there, and the planet is blasted by about the same stellar radiation Earth gets. Could we ever live there? K2-18b likely has an immense hydrogen envelope surrounding any watery areas, with a rocky core buried beneath. The planet's atmosphere may be so thick that the pressure would crush a terrestrial craft instantly, no stable surface to land on, and intense pressure that would smash anything we send. So, while it's exciting, K2-18b probably can't be our new home. First identified in 1999, TRAPPIST-1 is an ultra-cool red dwarf star, slightly bigger than Jupiter, about 39.46 light-years away. In February 2017, NASA announced 7 Earth-sized rocky planets in orbit around it, each with the potential for liquid water. Follow-up research in 2018 suggested these 7 might possess even more water than Earth. At least 3 lie at just the right distance to support liquid oceans. Using the Hubble Space Telescope, astronomers concluded TRAPPIST-1b and c probably aren't hydrogen-heavy gas giants, but scorching worlds reminiscent of Venus, although lacking sulfuric acid clouds. TRAPPIST-1d has half Earth's gravity, a compact atmosphere, and orbits along the inner habitable edge, possibly icy or watery, but new findings hint it could be more Venus-like. TRAPPIST-1e is the closest in mass, gravity, and temperature to Earth, making it the strongest candidate for an ocean world. TRAPPIST-1f might be covered in an ocean beneath a hot, high-pressure steam atmosphere, enriched with abiotic oxygen, though still possibly uninhabitable. TRAPPIST-1g similarly might be topped by thick water layers and oxygen, while TRAPPIST-1h likely remains a frozen sphere at around 155 degrees. Since these planets are probably tidally locked, each might have a temperate zone shielded from stellar radiation. Many questions remain, but the TRAPPIST-1 system is the most deeply studied group of exoplanets we know. Soon, the James Webb Space Telescope, a crowning triumph of space science, perhaps the most iconic unmanned craft since Sputnik, will turn its gaze toward the TRAPPIST-1 worlds. Slated to launch on October 31, 2021, its main objective is to examine exoplanet atmospheres in near-infrared detail, potentially identifying signatures of life. Astronomers will deploy JWST's near-infrared spectrograph to split starlight into its elemental fingerprint, telling us about temperature, mass, and chemical makeup. Molecules like oxygen leave distinctive lines in this spectrum, which helps reveal the planet's physical conditions. Thus far, over 4,000 exoplanets have been catalogued, many of them in the habitable zone. Oxygen in a planet's atmosphere is particularly exciting. On Earth, photosynthesizing organisms generate about 20% of our atmosphere's oxygen. With the JWST's superior data, we can watch for oxygen collisions in alien skies. Atoms or molecules knocking together block certain wavelengths of infrared light, a phenomenon telescopes can detect. However, life may not be the only origin of oxygen, and some planets lose their oceans to space, leaving surplus oxygen behind. Still, technology is finally within reach to unravel whether a planet is living or dead, and the growing sense is that we'll soon find out we're not alone. Are you thrilled for what the James Webb Space Telescope will discover? Could we detect life at last? Share your thoughts. Stay tuned as the pace of discovery quickens. At any moment, we might finally spot life on a super-Earth. Scientists have long been discovering exoplanets that could support life, and there are hundreds of millions waiting to be found. Though our planet is unique to us, new evidence hints that worlds superior for life might exist, orbiting foreign stars. Any planet beyond our solar system is an exoplanet, and these vary from gas giants exceeding Jupiter in size to small rocky spheres akin to Earth and Mars. The majority of known exoplanets reside near our corner of the Milky Way. NASA's Kepler Space Telescope mission suggested more planets than stars in our galaxy, with the 1990s marking the earliest detections. Yet pinpointing them is tricky. There could be at least 300 million potentially habitable exoplanets here in the Milky Way. Kepler's 9-year planet-hunting mission ended when it depleted its fuel in 2018, having revealed thousands of exoplanets. After poring over its vast trove of data, astronomers concluded that roughly 300 million rocky planets might host liquid water. Considering there are 100 to 400 billion stars in the Milky Way, each presumably with at least one planet, the total might soar to trillions. It's easy to assume we can just see these planets with a telescope, but direct imaging is rare. Instead, We mostly use methods like transits, observing a star's faint dimming when a planet passes in front, or measuring the star's spectrum for shifts caused by the planet's gravitational tug, or even the gravitational lensing effect. These techniques, especially when combined, are accelerating our daily exoplanet discoveries. Habitability hinges on a planet's distance from its star, ensuring it's warm enough for liquid water, but not so hot that water evaporates, or so cold that it remains locked in ice. The star's type also matters. Stable stars, like our Sun, last long enough for life to evolve. Proxima b, found in 2016, just 4.2 light-years away, orbits a red dwarf named Proxima Centauri. With at least 1.3 Earth masses, it falls squarely in its habitable zone, hinting that it might support liquid water. Some bold thinkers imagine that, if we could reach Proxima b, we might confirm life. Then, in the same year, Proxima Centauri unleashed a solar flare 1,000 times brighter than the star itself, bombarding the exoplanet with 4,000 times more UV radiation than Earth receives from a solar flare. Any life there may have been annihilated by that single event. Yet scientists have now identified 24 so-called superhabitable exoplanets, or exomoons, potentially even more suitable for life than Earth is. The term superhabitable arose from research in 2014, wherein astronomers Renee Heller and John Armstrong noted that habitable zone placement alone isn't enough. These exoplanets might be older, bigger, warmer, with higher oxygen, orbiting longer-lived stars. They propose 2 Earth masses to maintain plate tectonics and a protective magnetosphere for far longer. The stronger gravity might hold an atmosphere more effectively, while more land area encourages biodiversity. Planets in stable orbits around K-type orange dwarfs might have 17 to 70 billion-year lifespans, far exceeding our Sun's 10 billion. That extra time fosters more advanced life. Kepler 442b is one example. Another is Gliese 667 cc, residing 23.62 light-years away in a triple-star system. Though it weighs in at 3.7 Earth masses, you'd see 3 stars from its surface. Kepler 452b, famously nicknamed Earth 2.0, orbits a G-type star akin to ours, but 1.5 billion years older. Some speculate an ancient civilization or advanced biosphere might have once thrived there, or that we glimpse Earth's eventual fate as our Sun swells into a red giant. We still can't detect oxygen in alien atmospheres, yet. That is about to change with the James Webb Space Telescope's 2021 launch. Using unparalleled optical design and next-generation instruments, it will glean unprecedented details about exoplanets. Positioned nearly 1 million miles from Earth, JWST can detect the subtle infrared signatures of chemical elements. If oxygen's discovered, we might have found life, as oxygen typically pairs with biological processes, though not exclusively. Meanwhile, the Nancy Grace Roman Telescope, set for the late 2020s, will boast 100-fold the field of view of Hubble, enabling direct imaging of exoplanets, along with studying dark matter and dark energy. With these new windows into the cosmos, we might spot the unimaginable, worlds more habitable than Earth. All this underscores that the universe is infinitely varied. True, superhabitable planets may not look anything like Earth. We live in exciting times. Considering the staggering quantity of exoplanets, it's highly probable we'll find life soon. Kepler's legacy proves it. In its 9-year lifespan, it scanned over 500,000 stars and verified more than 2,600 exoplanets, including ones unimaginable in our solar system, like enormous, hot Jupiters with scorching surfaces or multiple stars. Some might see sunsets in binary pairs. Its greatest achievement is demonstrating that Earth-like planets are out there, orbiting at safe distances in their own star systems. One remarkable discovery, K218b, has recently stirred much excitement. Strong indications of liquid water in its atmosphere. Standing 8 times Earth's mass, it orbits a red dwarf star named K218, about 124 light-years away. Water, that elixir of life, is present in its thick skies. Another world, Kepler 186f, found in 2014, might have stable seasons and climate, thanks to its similar spin and axial tilt. In 2020, researchers revisited false positives from old Kepler data, cross-checking them with test data to confirm the newly validated exoplanet Kepler 1649c, just 1.06 times Earth's size, and receiving about 75% of Earth's stellar light, making its environment comfortably temperate. Out of Kepler's thousands of finds, just 16 lie in the habitable zone. Yet some may be tidally locked, or more Neptune-like than Earth-like, or battered by intense flares from a restless red dwarf star, or endure extremes that bounce between 100° and 116°, Antarctic freeze to blazing desert. We lack the tools to determine their exact atmospheres or surfaces, though no one is giving up. Kepler taught astronomers a vital statistic. About 1 in 5 Sun-like stars could host an Earth-sized planet in its habitable zone. Since roughly 20% of stars in our galaxy resemble the Sun, that implies billions of such planets in the Milky Way alone. Kepler also unearthed myriad bizarre worlds ineligible for life as we know it, like hot Jupiters, tidally hugging their stars so closely that years last mere days. Some endure star-facing temperatures high enough to liquefy rock, creating molten hemispheres. Others revolve around binary stars, allowing a double sunset in the sky. But Kepler's crowning legacy remains its identification of small, rocky, temperate exoplanets. One enthralling instance is KOI 5ab, nearly dismissed in 2009 as messy data. A subsequent finding proved it orbits within a 3-star system, unraveling the complexities of planet formation in multi-star environments. Kepler left service on October 30, 2018, after running out of fuel, a day that coincidentally fell on the anniversary of the death of its namesake, Johannes Kepler, 338 years prior. Its good-night command from Mission Control was a poignant close to a game-changing observatory. Yet, its data trove continues to yield new treasures. In 2021, the James Webb Space Telescope will expand on Kepler's discoveries, investigating planetary atmospheres in detail for chemical signatures of life. Will astronomers uncover even stranger worlds buried in Kepler's data? We can't wait to find out. Share your thoughts below. Our collective exploration of the cosmos is accelerating, and each new telescope is another step toward resolving that eternal question. Are we alone